Hey, how's it going, guys? Today I'm going to show you a quick tutorial on how to use Quartus using the files that Ed sent us. So the first thing we're going to do is go ahead and open up Quartus. And we're going to want to go to the new project wizard, which will help us start a new project. Click Next. And I like, first thing we need to do here is set up a working directory for the project. And I like to just put it in the Intel FPGA Lite directory first, and then create a directory name that I'll remember. So for this I'll use Helicity tutorial. And I'm going to put a 1 in there because I messed up on the previous one. And now we can create a project name. And these don't have to be the same. This can be different than your directory name. Just is up to your discretion. We'll go ahead and create it. We'll click Next here. Here we can add files to the project. And so assuming at this point that you've downloaded Ed's files to your computer, we can go ahead and click here, and I saved Ed's files back in the FPGA Lite directory, and these are his files here. And so we're going to want to include every single one of these files except for the Helicity fit, because this particular file is used exclusively in the timing simulation portion of the project. So we'll go ahead and just select all of these. And go ahead and click open. And so now we can see all the files that we want to add. And now we can go ahead and click Next. And here we can choose the device that we want to use to upload the files to when we do so. And right now this is not incredibly important. We haven't exactly decided what FPGA board we're going to use, but I just go ahead and use the Cyclone 5. It's the newest board. And other than that, this is nothing, not much we need to do here. So we go ahead and click Next. Here, simulation, this is for running timing simulations, and either Model Sim or Model Sim Altera. I usually choose Model Sim Altera, and here I'll go ahead and choose VHDL, because I think that's going to be the primary language that we're going to run at. A lot of these things we can go back and change later, so if we decide we want to program in Verilog, we can go back and change this option later on in Quartus. So we'll click Next. And with that, we're done. The new project wizard, we can go ahead and create the project by clicking Finish. And there we go. So the first thing we need to do is we need to set our top level design. And so what we can do is go here and look at our files. So here's all the files that we've added to the project. And we need to choose a top level design so that the program knows which files instantiate one another. So we'll go ahead and open up Helicity Top, and what we can do is we can go to Assignments, or Project rather, and we scroll down to Top Level Design, set as Top Level Design Entity. So it'll set whatever file we just selected as the top level design, which is Helicity Top. That's the file we want to be the top level design. And we can go back to the hierarchy, and we can see here that the file Helicity Top was set as our top level design. So we can open up a couple of these files that are kind of important. One of those is Helicity Cycle, and the other is Helicity Recover. And what Helicity Cycle is going to do, it's going to be the file that creates our pseudo-random pseudo-random Helicity signal for the project. This is going to be where most of our inputs are. So we can see here that these are all the inputs to the Helicity board. And Helicity recover is the file that essentially creates the decoder portion of the project. So the next thing we're going to want to do here is we're going to want to see if we can get these files to compile. So we're going to go ahead up here and click Start Compilation. And this is probably going to take a little while. And a good way to tell if it's working correctly is that the analysis and synthesis task gets completed. So it'll take a few seconds to get going, and this is a good sign right here that we might have a successful compilation with very few or no errors. So while that's happening, we can talk about some of these files. And for this particular project, there are a couple of different languages that we can use. One's Verilog and one is VHDL, and both of them are pretty intuitive, and there are resources from them. But so far, we've chosen to use VHDL for most of the project because there seems to be more resources for it. And by resources, I mean that according to Ed, there is not exactly a Verilog expert at the lab if you need to ask questions, but there are plenty of people that are familiar with VHDL that could answer any questions that you have. So we've chosen to use VHDL, and one of the ways we can tell that is we've called a library here, which we don't do in Verilog, and this entity block here is also a telltale sign, along with the architecture block. That's a telltale sign that we're using VHDL. And another thing we can talk about while this thing is still running, it'll be done soon, and we can tell it's done. We can check its progress here in the task window, and so we only have 2 more things to do here. But we can talk about there's an in-program simulation feature here, and if we go to File, New, we can do a couple of things. For instance, we can open up a new Verilog or VHDL file, which will pop up here in the editor window, and we can add a new file to the project. Or if we scroll down and look here at the university program, this is actually a waveform simulator that works right in Quartus, so that's sometimes very convenient, and we can talk about that in another video. And it looks like our compilation was successful. So that's it for this video, and in the next video we'll talk about another few useful features in Quartus. Thanks a lot.